Last time we learned how to solve quadratic equation using completing the square. Today we're going to learn solving quadratic equations by the quadratic formula. We have a quadratic function f of x equals ax squared plus bx plus c. To find zeros of the function, we set up ax squared plus bx plus c equals 0. When you solve this equation using completing the square, you get x equals negative b plus minus square root of b squared minus 4ac all over 2a. This is the quadratic formula. Do you know why it's so cool? The quadratic formula allows you to solve any quadratic equation even if you cannot factor it. An important piece of the quadratic formula is what's under the radical, b squared minus 4ac. This piece is called discriminant. The discriminant tells you that the number and types of solutions you will get. Since the discriminant is under a radical, think about what it means if you have zero discriminant, positive discriminant, or negative discriminant. Can you match which one is which? Do you think when the discriminant is 0, it is this? Or when the discriminant is positive, do you think is the graph look like that, since it's positive? And then when the discriminant is negative, do you think will the graph look like this? Let's see next presentation. This shows you value of the discriminant and nature of the solutions. When the discriminant is 0, think about square root of 0 equals 0. So when you think about quadratic formula, this part is 0 means only one solution. So your quadratic formula will have x equals negative b over 2a. There are only one solutions. In this case, the graph touches x-axis. When the discriminant is positive perfect square, you're going to have two real solutions. Why? Because think about perfect square number under the radical. It's going to be integer, and integer over integer will be rational numbers. So you will have two real solutions. When the discriminant is positive, not perfect square, you're going to have two real but irrational solutions. For example, square root of what? 13 is irrational number. So you will have two irrational solutions. And the last situation, when the discriminant is negative, you get negative number under the square root. That means two complex conjugates. So you're gonna get two imaginary solutions. Let's have some examples so the concepts are more tangible. Find the value of the discriminant and solve using quadratic formula. 2x squared plus 7x minus 11 equals 0. So your a is 2, your b is 7, your c is negative 11. The discriminant b squared minus 4ac will be 7 squared b squared minus 4 times a times c equals, what will be the number? 49 plus negative becomes plus 88. It becomes 137, which is what? Positive, right? But this number should be where? Inside the radical. So your solution will be negative b, which is 7, plus minus the square root of 137 all over 2 times a, which is 4. So even though it is positive number, it is not a perfect square, so you will get 2 irrational solutions. Let's see next example. Negative 2x squared plus 5x minus 6 equals 0. So your a equals negative 2, your b equals 5, your c equals negative 6. The discriminant equals, again, b squared minus 4 times a times c. So you will get what number? Think about it. So you get 25 minus 48, right? So equals positive or negative, right? Negative 23. So your discriminant at this time less than 0, negative number. So your solution set equals negative b, which is 5, plus minus square root of what? Negative 23 all over 2 times a, which is negative 4. Think about this number, square root of negative 23. That is same as square root of negative 1 times square root of 23. It is what? Square root of 23i. Because square root of negative 1 is I. So your x equals, the solution set equals 5 over 4 and plus minus square root of 23 over 4i. This is the a plus minus bi form of the complex numbers. So I'm done for today's lesson, and next time I'm going to show you how to use GeoGebra for quadratic function. Thank you.